Okay, today we are going to start lesson 3. It's about the symbolic representation of the function, okay, which is the polynomial functions. Okay,
Okay.
okay. I want to show you one simple point first. If there is a function, from x to y or x on y, okay,
Okay.
and this function, for example, f of x equals x squared. So this means if I want to get f of 3, so this means f of 3, I will substitute, okay, with 3 as a value for x. Okay, so this means f of 3 equals x squared, which is 3 squared. Okay, so f
Okay.
of 3 will equal 9. Okay,
Okay.
okay, let's remember some simple points from the previous lesson. Okay, we said that if there is a set of x, okay, and x is a function on y, okay, so we said that x is the domain, y is the codomain,
Omidor.
okay, codomain, and the set of images of the elements of set x by the function f is called the range, right?
Yeah, right.
Remember that if x is like this and y on the arrow diagram is like this, if there is 1 and 2 and here 3 and 4 and 5, so if there is one arrow from 1 to 3 and one arrow from 2 to 5, so the range will equal the set of that images on y, which is 3 and 5. Okay,
Okay.
okay, and we said that on the range we will not repeat any element like this. If there is a set of x and a set of y, 1, 2, 3, and here any other elements like 5, 6, 8. Okay, if there is one arrow from 1 to 5 and from 2 to 6 and 3 to 6. So in this case, we said that this one is a function, okay, because all elements on x, okay, only have one arrow to y, or only have one image on y, or appears only one time as a first projection in the ordered pairs. So now the range will equal the set of 5 and 6. 6 here is repeated, but we have to write it only one time. So 5 and 6 only. Okay?
Okay.
Okay, so let's solve one example. Let's solve one example. So now the next example, okay, if x will equal the set of x equals the set of -1 and 0 and 1, and the set of y will equal 0 and -1 and -2, and there is a function from x to y. It's a function already, okay, where f of x equals x squared or x power 2 minus 1. Find the set of the function. Find the set of the function and represent it using arrow diagram and write its range. Okay, so here f of x equals x squared minus 1. Okay, so now if we want to get the relation or the function here, the set of the function, first one, what are the elements on x? It's -1 and 0 and 1. So first I'm going to use these values as values of x and substitute with these values on the function. So first f of -1, then f of 0, then the last one f of 1. I'm using these values, -1, 0, and 1. Okay? So f of -1 now, and the function x will equal -1. So this means -1 squared minus 1, which is -1 squared means 1. 1 minus 1 means 0. Okay? Okay. F of 0, it will equal also x squared, which is 0 squared minus 1. So it will equal 0 squared means 0, minus 1 means -1. And then f of 1 will equal x squared, which is 1 squared minus 1. 1 squared means 1, so 1 minus 1 equals 0. Now, I will write down, okay, the set of the function. Okay, how to get the set of the function? F of -1 equals 0. So the first ordered pair is -1 and 0. Okay, 0 equals -1. So 0 and -1. Then the last one, 1 and 0. So 1 and 0. So the set of the function, okay, will equal the set of the function. I will write it here. Set of the function f will equal the set of first one, -1 and 0, -1 and 0, and the second ordered pair, 0 and -1, and then the last ordered pair, 1 and 0. Okay? This point is clear? Okay, so next point, find the range. Abdurrahman, what will be the range here? The set of the function, -1 and 0, 0 and -1, and 1 and 0. So the range will equal the set of 0 and -1 and 0, but we said that we will not repeat any element. So only 0 and -1. I will not write 0 again because I'm not repeating elements. Okay? Now this question
Okay.
is clear?
Yeah, it's clear.
Okay, very good. Very good. Okay. Then the next question, if the function is from n to n, where n is the set of natural numbers, and f of x equals x plus 1. Okay, find f of 0, f of 1, f of 2, and f of 3, and f of 4. Okay, then graph a part of the square net of the Cartesian product and represent on it 5 elements, okay, of this function, and then mention the range.
Okay.
Okay, how to solve this one? Actually, it's very easy. It's like that one before. Now f of x equals x plus 1. I want to get f of 0,
Okay.
right?
Yeah,
F of
it's
1,
0 plus 1.
exactly, and f of 2. First, I will write all of them, f of 3, and finally f of 4. Okay, so f of 0 will equal, where is my function? This is the function. F of 0 means I will substitute with the value of x equals 0. So x plus 1, which is 0 plus 1. So it will equal 1.
1.
So now the ordered pair here is 0 and 1. So 0 and 1. F of 1 equals x plus 1. So 1 plus 1, which will equal 2. So the
2.
ordered pair now 1
1 and 2.
and 2. Great. F of 2 equals 2 plus 1, which is
1,
x plus 1. So it will equal 3. So the ordered pair 2 and
2 and
3.
3.
Great. Now f of 3 will equal x, which is equal now 3 plus 1. So it will equal 4. So the ordered pair 3 and 4. The next one, f of 4, it will equal also x, which is 4 now, plus 1. So it will equal 5. So the ordered pair, 4 and 5. Okay. So now we got f of 0, f of 1, f of 2, 3, 4, and 5. Okay, 4. Okay, then graph the part of the Cartesian perpendicular net. Okay, and they represent this 5 elements. Okay, it's very easy. I'm going to clear this part, and only I will keep the ordered pairs. Okay, so that we can draw the Cartesian diagram. Okay. So now, as we said before, how to draw the Cartesian diagram. It's given in the question that the function is from n to n. Okay, so now this one will be n, and this one also n. Okay, so n to n. What are the elements? There is 1, 2, 3, 4, 5, and here 0.
This
And
question in the
1,
paragraph.
2, 3, Cartesian diagram, 4, 5, and so on. Now, draw the vertical lines as usual, okay, like this, and horizontal lines to the remaining elements here, like this. Okay. Here the function is from n to n, means natural numbers. So I have to write down 0, 1, 2, 3, 4, 5, like this. But in the question, okay, it's mentioned that only represent on it 5 elements. Okay, the 5 elements, which is 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5, like this. Okay? Okay.
Okay.
Now the first point is 0 and 1. So 0 and 1, it will be this point. Then 1 and 2, this point, 2 and 3, this point, 3 and 4, this point, and then 4 and 5, this point. So this is the Cartesian diagram for these 5 elements. Okay, then find the range. Find the range. Actually, here the function is from n to n, so this means the whole natural numbers. Okay, so the range here, range will equal, okay, actually the function is x plus 1. Now, if x even equals 0, natural numbers means starting from 0 and 0, 1, 2, 3, 4, 5, 6, and so on. So if x equals 0, we found that f of x will equal 1. Okay, and so on. And each time, okay, the value of the function increased by 1. So first time 1, then 2, then 3, then 4, then 5. Then if we will continue 6, 7, 8, and so on. So now the range is 1 and 2 and 3 and 4 and 5 and 6 and 7 and so on, right?
Right.
So this means it is all elements of the natural number except 0, right?
Right.
So this means that the range will equal the natural numbers, which is n minus what? Minus the set of 0. Okay, because this function will never equal 0 because it's x plus 1. So if we will start with the smallest number on the natural numbers, which is 0, so the function will equal 0 plus 1, which is equal 1. So the range will never be 0. So this means all numbers, all natural numbers except 0. So in this case, the range will equal natural numbers minus the set of 0. Okay?
Okay.
Now this one is clear?
Yeah, it's clear.
Okay, great. Now let's solve the next question. If x equals the set of 2, 4, 6, 8, 2, 4, 6, 8, and y equals 1, 2, 3, 4, 5, 6. Okay. And the function is from x to y, okay, where f of x equals half x, sorry. Okay, f of x equals half x. Okay, write the set of the function and represent it by Cartesian diagram and find the range. Okay, so now f of x equals half x. Okay, no problem. What are the elements of x which I'm going to use? It's 2 and 4 and 6 and 8. So I have to get f of 2, f of 4, f of 6, f of 8, right? So first, f of 2 will equal 1 over 2 times x, which is 2. So it will equal 2 over 2, which is equal 1. Okay, then f of 4 will equal 1 over 2 times 4, which will equal 2. F of 6, 1 over 2 times 6, which will equal 3. F of 8, 1 over 2 times 8, which will
Equal
equal
4.
4.
4.
So now the ordered pairs, the first
Uh-huh.
one, when x equal 2, f of x equals 1. So the first ordered pair or the set of the function will equal the set of 2 and 1, then 4 and 2. Okay, then 6 and 3, 6 and 3, then 8 and 4, 8 and 4. Representing this one using a Cartesian diagram, it will be very easy as usual. But now I want to get the range. The range will equal the set of. We said that the range always is the second projection. So 1, 2,
2,
3.
3, 4.
So the range is equal the set of 1 and 2 and 3 and 4. That's it. So this question is clear?
That's clear.
Okay, very good. So now let's start the next part. Next part is about the polynomial functions. Polynomial functions. Okay, actually, the polynomial function is a function whose rule is a term of an algebraic expression. Okay, but there are some conditions. Okay,
Okay.
so in this case, each of the domain and the codomain of the function is the set of real numbers, and then the power or the index of the variable x in any of its terms is also a natural number. Like what? Like I'm going to write some functions which are polynomials. So like f of x equals 2x plus 5. So this one actually is a polynomial. If it's f of x equals x squared minus 2x plus 1, so also this one is a polynomial. If it's f of x equals 7, for example, also this one is a polynomial. If it's f of x equals 1 plus a square root of 2x minus 9x power 3, also this one is a polynomial. Okay?
Okay.
Okay, so this means the domain and the codomain, okay, of the function is the set of real numbers. But if the domain or the codomain of the function is not a set, okay, of real numbers, this means the function is not polynomial. Like what? Okay, there are very little conditions, okay, sorry, I mean cases, so that the function is not polynomial. Like what? Like this one. if f of x equals a square root of x. So if there is a function and there is one term, okay, of them is the square root of x, okay, of x, not a number. Square root of 2 is accepted. Square root of any number is accepted. But if it's a square root of x, so this means not polynomial. So the first case, the square root of the variable, okay? It's not a polynomial, okay? Why? Because actually, okay, if there is f of negative value, it will equal, in case of square root of x, it will equal square root of -1. We don't have negative square roots, okay? Only positive, okay?
Okay.
Till now, we are studying only the positive square roots, okay? So this is not accepted. So the square root of x means it's not polynomial, okay? What else? What else? If it's one of the terms is 1 over x. So if there is a function like this one, terms, then 1 over x like this. So this is not
Sorry,
polynomial.
mister. My phone is called.
Okay, no problem. Take your
One,
time.
1 minute.
Okay, so if it's 1 over x, also not polynomial. Why not polynomial? Because if I will ask about this function, f of x equals 1 over x. Now get me the f of 0. So now it will equal 1 over 0. Actually, this is not defined. So also 1 over x, it's not polynomial. So now a square root of variable, which is x or x squared or whatever, okay, this one is not polynomial. If it's 1 over the variable, which is x, or 1 over x squared, or whatever, also not polynomial. Okay, one more small point. If it's x at the power of -1, okay, actually, x at the power of -1 means it equals 1 over x. So also, if there is a negative power for the variable, so this means not polynomial. Okay, are we
Okay.
clear till now?
Yeah, it's clear, right?
Okay. Also, if we want to check if this function is a polynomial or not, okay, we have to simplify it, okay, in the simplest form. Okay, like what? Like if there is 3x plus 2 plus 5x, like this, okay? We have to simplify it. We have to add 3x plus 5x so that we can get 8x plus 2. Then we will decide if it's a polynomial or not. Okay, I'm giving a simple example. Okay?
Okay.
Okay, so if this one, if it's like this one, x times x plus 1 over x. This one is a polynomial or not? Actually, this one is not a polynomial. Why? Now we can multiply this one to this one, so it will equal x squared plus x times 1 over x. It will equal x over x, which is 1. Okay?
Okay.
Okay, but actually this one, okay, now is a polynomial. Okay? So
Okay.
this one is not a polynomial because f of 0 means 1 over 0 here. So this is not a polynomial. Okay?
Okay.
But f of x equals x squared plus 1, actually this one a polynomial. Okay?
Okay.
Okay. And then the next point in this lesson is about the degree of the polynomial function. Okay, if there is a function like this, f of x equals 3x minus 1 over 2. I said that I don't care about the numbers. If it's a fraction, 1 over 2, okay. So this one is a polynomial, but I'm going to refuse it if it's 1 over x, right? So in this case, actually, this one is a polynomial. Okay, now this one, at which degree? Here, it's x, 3x, and now x, of course, by default, it's at power 1. So this one at the first degree. Okay, so this one is at the first degree. First degree means linear function. Linear function.
Linear function.
Linear function. Okay, so first degree means linear function.
Function.
Okay. If it's not at the power of 1, x not at the power of 1, like power of 2, like this one, f of x equals the square root of 5, x squared. I don't care about the number, square root of 5, 3, it's accepted. I only will refuse the square root of variable, right?
Right.
So this one, square root of 5, x squared minus 3x plus 4. So now, where is x here? This one and this one. What is the highest power here? Actually, power of 2. So this one is at the second degree, right? Second
Right.
degree. So this one, it's a quadratic function. Quadratic function. So if it's at the first degree, so linear function, second degree, quadratic function. Okay, the last one, if it's like this, f of x equals x power 3 minus 5x power 2 plus 4. Okay, now x and x, what is the highest degree here? Or the highest power? Actually, it's a 3. So this one at the third degree. Third degree means cubic function. Okay? So again, first degree, linear. Second degree, quadratic. Third degree, cubic. Linear means first degree, so this means x at the power of 1. Second, x at the power of 2, or the variable generally at the power of 2. Here, cubic at the power of 3. Okay? Okay, so let's check some questions.
In the cubic. Can I tell him cubic if I have two x with a different sign with
Like
different
what?
power?
Like what different power? Like x power 3 plus 3, or yes, 3x power 2
Yeah.
plus 5. Now I'm going to check the highest power. So now this one, cubic, third degree. Okay?
Okay. If the two
Okay.
is first.
First, only x, like this. If it's f of x equals x plus 5. So the highest power here is 1. So this one first degree, so linear. Okay?
Okay.
If this power is x power 2, so second degree. So second degree, quadratic. Okay, now it's clear?
Yeah, it's clear.
Okay, if it's like this, f of x equals 5. Now this one, okay, has no degree, okay? Has no degree. So we can write down this one at the 0 degree. Okay?
Okay.
Okay, 0 degree, we have to say that this one is constant function. Constant function. Constant function means its value never changes. F of x always equal 5. So this means f of anything inside the bracket here have to equal 5 if f of x equal 5. Okay?
Okay.
I mean that if f of x equal 3, so f of 1 equal 3, f of 5 equal 3, f of negative x also equal 3, f of whatever between the brackets here equal 3. Okay?
Okay.
Okay, great. So let's start solving some examples, okay, related to the polynomials and its degree. Okay, now mention the degree of each of the following. F of x equals 5 minus 3x. Now, this one, do we have a variable like x or y or whatever? Yes, this one. At which power? 1.
One.
Okay,
It's
so this
a linear
means
function.
this one is the first degree. If they asked about the degree, then we have to write down first degree. Then we can write down linear function, no problem. But, okay, we have to write first degree,
First
okay,
degree.
linear
Okay.
function. Okay, the second one, if it's f of x equals 3x minus x squared. So where are the variables x and x squared? Which one is the highest power? Of course, x squared. So second degree, okay, which is quadratic. Okay, one more. If it's like this one, f of x equals 5x minus 3x squared plus x power 3. Now, there is x here, here, here. What is the highest power? Of course, a 3. So this means third degree. Okay? This one is clear?
Yeah, it's clear.
Okay, great. Now, concentrate on the next one. If it's like this, f of x equals x squared times 2 plus x all at the power of 2. We said that before we get the degree, okay, we have to simplify this one, because by default, if you will look at this one, you will say that yes, of course, the highest power here is 2, so second degree. Actually, second degree is wrong. Why? Because we have to simplify it first. Okay, so how to simplify? Simplify this bracket and then multiply to x squared. So this means f of x will equal x squared times, it's 2 plus x squared. So how to simplify this one? We studied a simple rule before, okay? If it's a term plus term or a term minus another term squared, so it will equal the first term squared, which is 2 squared means 4, then plus, so plus 2 times first term times second term. So 2 times 2 times x. So 2 times 2 means 4 times x means 4x. Then the second term squared, which is x squared. Okay, it's that rule. A plus b squared equals first term squared plus 2ab, which is 2 times first times second, plus second term squared, which is b squared. If it's a negative, a minus b squared, it will be the same. The only difference will be on the middle sign. So also here, first term squared then negative in this case, 2 times the first times the second, 2ab plus second term squared, which is b squared. Okay, then now simplify this one. How to simplify it? I have to multiply this term by 4 and this term by 4x and this term again by x squared. So it will equal 4x squared plus x squared times 4x, 4x power 3, then plus x power 2 times x power 2, x power 4. Now it becomes x power 2, x power 3, x power 4. So what is the highest power here? Actually 4. So this one at the 4th degree. Okay? So that we have to simplify the function to get the degree of this function. Okay? Are we clear till now?
Yeah, it's clear.
Okay, very good. Then let's continue to the next one. If it's like this, if f of x will equal x times x power 3 plus x power 2, then minus x squared times x squared minus 2x. Okay, I want to get the degree of this one. Okay, so as usual, I have to simplify this one. How to simplify it? Now I have to multiply this x times this one and times this one. I will multiply x to the whole elements inside the bracket. So x times x power 3, so this means it will equal x power 4. Then plus x times x squared, x power 3. Okay, then negative. Then one more bracket like this. X squared times x squared means x power 4. Then x squared times negative 2x means negative 2x power 3. Okay, now simplify it, x power 4 plus x power 3, then negative x power 4. Then there is a negative sign outside the bracket, so negative and negative means positive 2x power 3. So simply now x power 4 and negative x power 4, so this means 0. So it will equal x power 3 plus 2x power 3. So this means 3x power 3. Now it becomes at the power of 3, so third degree. Okay?
Okay.
Okay, now this one is clear.
Yeah, it's clear.
So we have to agree that, okay, we have to simplify the function to get the degree, okay?
Yeah.
Okay. The next question, which of the functions are polynomials or not, okay, and determine its degree. Okay, the first one, it's f of x equals x times x squared minus 3. Okay, so in this case, I have to simplify this one so that I will know the degree of that one. Okay, so f of x here will equal x times x squared means x power 3. Then minus x times 3, it will equal, sorry, I mean x times negative 3, so minus 3x. Okay, so now this one, add the third degree because the highest power is 3, so third degree, and of course it's a polynomial, right?
Yeah,
Okay,
right.
then the next one, it will be like this. If it's f of x equals x times 2 over x plus 5. Okay, this one is a polynomial or not? Of course, not polynomial. Why? Because here 2 over x, we said that we will refuse that cases 1 over x, if x in the denominator, or a square root of x, or x at the power of negative, right? So this one
Right.
2 over x, so x in the denominator, so this one is not a polynomial. Okay, so there are no degree or anything. Okay, then the next one, if it's x, f of x, I mean, will equal x squared minus square root of x plus 1. So this one is a polynomial? Of course, no. Why? Because there is a square root of x. Okay, so this is not a polynomial. Okay. One more. If f of x equals x squared minus x squared minus 4. Then I have to simplify this one. X squared minus x squared. Then negative here and negative here. So minus negative 4 means plus 4. Now it will equal, this is x squared, and negative x squared means 0. So it will equal only 4. Right? So this one is a polynomial. Yes, it's a polynomial. And at which degree? Only number. So 0 degree. Okay? Are we clear till now?
Yeah, it's clear.
Okay, very good. Very good. So let's solve some examples also. Okay, the next example. If f of x equals x squared minus 2x plus 5. Find f of 1, f of 0, f of negative 2, f of 1 over 2, and f of square root of 5. Okay, how to solve this one? Actually, it's very easy. We said that we will substitute, okay, in the function, this one with these values. So f of 1 means x will equal 1. So x squared means 1 squared minus 2 times x, which is 1, plus 5. So f of 1 will equal 1 squared, which will equal 1, minus 2 times 1, which will equal 2, plus 5. So in this case, 1 minus 2 equals negative 1 plus 5, so it will equal 4. Okay, so f of 1 will equal 4. Okay, now we want to get f of 0. So now x equals 0. F of 0 will equal x squared means 0 squared minus 2 times x, which is 0, plus 5. So it will equal 0 minus 2 times 0, also 0, plus 5. So f of 0 will equal 5. Okay, now get f of negative 2. F of negative 2 will equal x squared on the main function, which is negative 2 squared, minus 2x, which is minus 2 times negative 2, plus 5. So it will equal negative 2 squared means 4. Negative 2 times negative 2 means positive 4 plus 5. So it will equal 8 plus 5, 13. So f of negative 2 will equal 13. The next one, the next one, f, we finished f of negative 2, then we have to get f of 1 over 2. So let me clear this part, okay, about f of 1 and 0 and continue. Okay, now I'm going to get f of negative 2. So now this means f of, f of 1 over 2. Now this means x will equal 1 over 2. So x squared means 1 over 2 squared minus 2 times x, now 1 over 2, plus 5. So it will equal 1 over 2 squared means 1 over 4, minus 2 times 1 over 2 means 2 over 2, which will equal 1, plus 5. So simply this one will equal -1 plus 5, which is 4. Okay, 4 plus 1 over 4, so 4 and 1 over 4, like this. Okay,
Okay.
the last one, it's f of a square root of 5. Okay, so now the value of x equals the square root of 5. So where is the function? This one, f of x equals x squared. So square root of 5 squared minus 2x means 2 times the square root of 5 plus 5. Okay, so it will equal square root of 5 squared means square root of 5 times itself. So it will equal 5 minus 2 square root of 5 plus 5. Okay, so in this case, f of square root of 5 will equal this one, 5 plus 5 means 10. So it will equal, let me clear this space on the board. Okay, so it will equal 10 minus 2 square root of 5. Okay,
Okay.
now this one is clear.
Yeah, it's clear.
Okay, great. Then the next part also in this question, we finished the first part to find f of 1 and f of 0, f of -2, f of 1 over 2, and f of square root of 5. And we said that it's very easy. Just I'm going to substitute with the value of x, which is given like f of 1. So now x will equal 1. And then use 1 to substitute with it instead of each x and the main function. Okay, now the second point, prove that f of 2 square root of 2 plus 1 equals 2f of 1 minus the square root of 2. Okay, it's very easy. First, I have to get f of 2 square root of 2 plus 1. This one I mean. Okay, so this one, f of 2 square root of 2 plus 1 will equal, now x will equal this value. Okay, so it will equal, where is the function here? X squared. So it will equal 2 square root of 2 plus 1 squared minus 2x. So minus 2 times x, which is 2 square root of 2 plus 1. Then plus 5. So plus 5. Now it will equal 2 square root of 2 plus 1 squared. Okay, how to simplify this one? As usual. Okay, the first term squared plus 2 times the first times second. Okay, then plus the second term squared. So first term squared here means 2 square root of 2 squared. Okay, so 2 squared means 4. Square root of 2 squared means 2. So 4 times 2 means 8. Plus 2 times the first times second. So 2 times 2 square root of 2 times 1. So plus 2 times, which will be equal 4 directly. 2 times first times second, 4 square root of 2. Then plus the second term squared, which is 1 squared, so 1. Minus 2 times 2 square root of 2, so minus 4 square root of 2. Then minus 2 again times positive 1, so negative 2. Then plus 5. Now simplify it. This one is 8. This one is negative 2. This one is 5. So 8 minus 2 means 6. Plus 5 means it will equal 11 plus this one, so it will equal 12. So 12, and this one positive 4 square root of 2 and negative, so this means 0. So this one, f of 2 square root of 2 plus 1 equal 12. Okay? Now I'm going to write down this value here. So this side equal 12. Okay, I will keep it here so that I will not forget the value. Now I'm going to clear the board so that I will get the value of this function on the right side. This one is clear now?
Yes, clear.
Okay, great. Then get this one. 2f of 1 minus the square root of 2. Okay. First, I will get only f of square root of 1 minus square root of 2. Then I will multiply it by 2. Okay. So it will equal x squared on the top, the function. So this means 1 minus the square root of 2 squared. Then minus 2x, so minus 2 times x, which is 1 minus the square root of 2, plus 5. Okay, so it will equal 1 minus the square root of 2 squared. It will equal the first term squared, so 1 squared means 1, minus 2 times the first times second, 2 square root of 2, plus second term squared, square root of 2 squared means 2. Then negative 2 times 1, so negative 2. Negative 2 times a negative square root of 2 means positive 2 square root of 2. And finally, plus 5. Okay, now it will equal here 1 plus 2, so 3 minus 2. Okay, means 1 plus 5, so 6. And this one negative 2 square root of 2 and positive 2 square root of 2. Same term with different sign means 0. So now f of 1 minus the square root of 2 equals 6. I want to get 2f. Okay, so twice the value of this one. 2f of 1 minus the square root of 2 will equal 2 times the value of the function, which is 6. So it will equal 12. So now this one also equal to 12. So that was the requirement to prove that this one equal to this one. We got that the left side equal 12 and the right side equal 12. So the two terms are equal. Okay? So now this one is clear?
Yeah, it's clear.
Okay, great. One more question. One more question. Okay, so the next question. If f of x equals 2x plus b, 2x plus b, and g of x equals x squared plus b, and f of 2 plus g of negative 4 equal 30. Find f of negative 2 minus g of 2. Okay, how to get this one? Actually, I have to get f of x and g of x, okay, without that variable because there is one unknown variable here, it's b, okay? So if I will get f of negative 2, okay, so it will equal, yes, okay, 2x, then what about b? So how to solve this one? It's a given on the question that f of 2, this one, plus f of plus g of negative 4 equal 30. Okay, so now I'm going to get f of 2 and g of negative 4 and add them and make them equal to 30 so that we can get the value of b. Okay, it's easy. So from this one first, f of 2 will equal, now f of x equals 2x plus b. So now x will equal 2 because I'm getting f of 2. So each x will equal 2. So f of 2 will equal 2x, means 2 times 2, which is 4 plus b. Okay. And then g of negative 4, this one, I'm going to get g of negative 4. So it will equal, where is g? This one. Negative 4 means x now will equal negative 4. It equals x squared. So negative 4 squared, which is 16 plus b. Are we clear till now? Okay. So it's given that in the question f of 2 plus g of negative 4 equal 30. So where is f of 2? This one. 4 plus b. So this means 4 plus b, which is f of 2, plus g of negative 4, which is 16 plus b. So now it will equal what? 30. So 30. So 4 plus 16 means 20, plus b means 2b equals 30. Now I can get the value of b. So now 2b, this one will equal, I'm going to shift this 20 to the other side with negative sign. So 2b will equal 30 minus 20 because I'm changing the sign. So 2b will equal 10. So simply I'm dividing by 2. So b only will equal 5. Okay, great. So now b will equal 5. So this means f of x will becomes 2x plus 5. And g of x will equal x squared plus 5. Now it's very easy to get f of negative 2 and g of 2. Okay, let me clear this part on the board. Okay, so here first I'm going to get f of negative 2 and then g of 2. Okay. First, I'm going to get f of negative 2, which is the first requirement here, f of negative 2. Where is f now? F of x is 2x plus 5. So this means 2 times negative 2, which is the value of x now, plus 5. So f of negative 2 will equal negative 4 plus 5, which will equal 1. Okay, then g of 2. Now get g of 2. So it will equal, where is g now? It's this one, x squared plus 5. So x equal 2. So g of 2 will equal 2 squared plus 5, which will equal 2 squared means 4 plus 5 means 9. Now in the question, find f of negative 2 minus g of 2. So f of negative 2 minus g of 2, okay, will equal f of negative 2, we got it. It equals 1. G of 2 equals 9, so 1 minus 9, so it will equal negative 8. And the question is finished. Now this one is clear?
Yes, clear.
Okay, very good. Okay, one more question, and concentrate with me on this question, okay? It will be like that questions we solved now, okay? So try to concentrate more so that if there is any point, you will understand it, okay? The next question, if f of x equals 2x plus 5 and g of x equals x minus 6. Okay, prove f of 2 plus 3g of 3 equals 0. Okay. First, I have to get f of 2, then g of 3, and multiply it by 3, and then add them so that we have to equal 0, so that I will prove that. Okay, no problem. So first, f of 2, where is f of x? So this one. Now x becomes 2, so 2 times 2 plus 5. So f of 2, sorry, I have to write here f of 2. Okay, it will equal 2 times 2 plus 5, so this means it will equal 9. Okay, then get 3g of 3. First, I have to get only g of 3, then I will multiply it by 3. G of 3 will equal, where is g? This one. X minus 3. Now x equals 3 here. So 3 minus 6. So it will equal negative 3. So what about 3g of 3? It will equal 3 times the value of g of 3, which is negative 3. So it will equal negative 9. Now, in the question, it's required that to prove f of 2 plus 3g of 3 equals 0. So you will check. F of 2 now, we got it. It will equal 9 plus 3g of 3. This one, it equals a negative 9. So negative 9. So 9 plus negative 9, actually, it will equal 0. And that was the required in this question to prove that f of 2 plus 3g of 3 equals 0. Okay, now this one is clear?
Yeah, it's clear.
Okay, great. Actually, that was lesson 3, okay, on unit 1. Uh, so now all these points are clear?
Yeah, it's clear.
Okay, great, great, very good.